So in this video, we want to look at an example. We have example 7. The General Social Survey asks questions about health and happiness. The table below provides the results. Assume the results are representative of all U.S. adults. So we have a table of information regarding health and happiness. So the columns regard health. So there were these people with poor health, fair health, good health, excellent health. And then we have the rows that are dealing with happiness. So we have these people who are unhappy, these people are pretty happy, these people are very happy. So, if a U.S. adult is selected randomly, what is the probability that the person is in excellent health and is very happy? So notice this question is an and question. This is an intersection question. We want to know what is the probability that if we randomly select one U.S. adult, that that person is in excellent health and is very happy, both. Well, altogether in this table, there are 65,394 individuals represented. And if we take a look, we have this column again that's regarding excellent health, and this row is representing very happy. So there are 5,095 individuals in this table that are in excellent health and very happy. So the probability in this case is going to be these 5,095 out of the total of 65,394. So 5,095 out of 65,394, that is going to be our probability. This is a nasty fraction, so we want to change this to decimal form. So if I bring in my calculator, 5,095 divided by 65,394, that is 0.078 if I round to 3 places. So this is approximately 0.078. So if I randomly select one U.S. adult, the probability that that person is in excellent health and is very happy is 0.078. Look at B. Again, if a U.S. adult is selected randomly, what is the probability that the person is in excellent health or is very happy? So similar question to what we saw in A, except the question is or. So this is a union question. So this will be the probability that they're in excellent health plus the probability that they're very happy minus the probability that they're in excellent health intersect with very happy. Well, the probability of being in excellent health, looking here at this column, altogether there were 11,022 individuals in excellent health. So this would be 11,022 out of 65,394. Plus, what's the probability of being very happy? Well, if I look across this row, there were 11,347 that are very happy. So 11,347 out of 65,394 minus what's the probability that they're in excellent health and very happy? Well, that's what we did up here in part A. That's 5,095 out of the 65,394. So if I add and subtract here, I'm going to use my calculator for this. So if I add up the 11,022 plus the 11,347, and if I subtract off the 5,095, that is 17,274. So there are 17,274 individuals that are in excellent health or very happy or both, out of the 65,394. So if I take that 17,274 and divide by 65,394, that is about 0.264. So this is 0.264. So if I randomly select a U.S. adult, there's about a 26.4% chance that that individual is in excellent health or is very happy. Look at C. If we randomly select a U.S. adult, what is the probability that the person is neither in excellent health nor very happy? Ooh, now this one's a little more challenging. Neither in excellent health nor very happy. So now we're dealing with a complement. So if the person is neither in excellent health nor very happy, that means they're not in excellent health or very happy, either one. So in other words, they're not in these 11,022 people, and they're also not in these 11,347 people. In other words, question C is the complement of question B. So question C is the complement of the probability of being in excellent health or very happy. So we're going to do 1 minus the 17,274 out of 65,394. So to figure that out, I'm going to take 65,394 minus 17,274. That is 48,120. So that is 48,120 out of the 65,394. So if I take 48,120 and divide by 65,394, that is approximately 0.736. So 0.736. Now I could have also have taken 1 minus the 0.264 that we found here in order to get that 0.736. So I could have also have found that directly using the decimals. So the probability that the person is neither in excellent health nor very happy is 0.736. And again, the simplicity here is to recognize that this is the complement of this. Now last but not least, let's look at D. If we randomly select a U.S. adult, what is the probability the person is neither in poor health nor unhappy? Neither in poor health nor unhappy. Well, recognizing that this statement is the complement of being in poor health or unhappy is the key to figuring out this probability as simply as possible. So we're going to find the probability of being in poor health, union, or unhappy. So we're going to figure this out, and then the answer to our question is going to be the complement of that. Well, the probability of being in poor health, if we go back up here to our table, the probability of being in poor health is 1,996 out of the 65,394. The probability of being unhappy is 4,553 out of the 65,394. And the probability of being both in poor health and unhappy is 696 out of the 65,394. So if I write that down, this is going to equal the probability of being in poor health plus the probability of being unhappy minus the probability of being in poor health and unhappy. So again, the probability of being in poor health is 1,996 out of the 65,394. So 1,996 out of 65,394 plus The probability of being unhappy, well, that is 4,553 out of the 65,394. So 4,553 out of the 65,394 minus the probability of being both in poor health and unhappy, that is the 696 out of the 65,394. So 696 out of 65,394. So if I bring in my calculator, 1996 plus 4553 minus 696, that is 5,853. So this is 5,853 out of 65,394. So again, if I take that 5,853 and divide by 65,394, that is about 0.090 if I round to three places, 0.090. So this is approximately 0.090. Now again, this is the probability that the person is in poor health or unhappy. That's not the answer to our question. Our question is, what's the probability the person is neither in poor health nor unhappy? So we have the complement of what we just found. So the probability of being neither in poor health nor unhappy is going to be 1 minus this. So that's going to be 1 minus, and I'm going to go straight to the decimal here, 0.090, and 1 minus 0.090 will be 0.910. So the probability, if I randomly select one U.S. adult, the probability that that individual will be neither in poor health nor unhappy is 0.910. So about a 91% chance of that. So at this point, we have completed all of our examples for section 13.2. You should be able to handle the section 13.2 homework.